And the other EM, they'll just have to live with the solutions I post because it's unrelated anyway. Which is too bad because it's really a cute problem. But it's too hard for an exam.
Well, it's cute and scary.
Yeah. It's a bad. Yeah.
It's the Kim Kardashian.
It was a collider. It was a collider.
I don't think we gotta make that reference.
It's a lot better.
She called it the Kim Kardashian.
The Kim Kardashian of questions.
I think that's
Cute,
too mean.
cute and scary. I don't know.
I think it's too mean.
All right, let me see. I actually already wrote the solution, so I want to not make too many mistakes. Okay. Yeah, what's up? Okay. Which, by the way, if you're just tired of not doing this, this is harder than the exam clearly. So if you're just worried about the exam, you don't care right now.
So that we don't care and then freak out Wednesday again.
Yeah, you can freak out Wednesday. That's exactly. If you want to procrastinate.
Tuesday past 9 p.m. free.
Yeah, exactly. If you want to.
Oh no, past 7:30, right? Or 7:30? 7:30?
We're still going to do neural nets quickly.
We can still freak out after the
Oh, I
exam
guess it's
and
true.
just
Yeah.
not pay attention to neural
You're
nets.
just going to see a sea of glazed eyes.
Yeah.
Is this deal with you? No? Okay.
Okay.
Kevin don't care.
Okay, I don't care. All right.
It's like a, what was it? Bad thing of chocolates? What was that?
Crappy box of
Crappy box of
Box of
chocolates.
crappy chocolates. All right. All right. I don't know how much I can keep both on the screen, but we'll see. So we found this. So actually, this is a real model, and I don't know why I didn't just keep the original model. So people do use mixture of Poissons to model survival rates for diseases. So I don't know what disease they have, but they have some mixture of afflictions, and they have some expected length to live. But it's recast here just as two. Yeah.
So just so I can be clear, a Poisson is when you have conditional independence on everything, but it's over a certain time period. So everything.
No, it's not conditional independence. It's a particular probability distribution. The thing interesting about Poissons is they're memoryless. So effectively, they don't have state. But what they output is they just output a positive integer, a positive integer, right? So I have some probability for any given word count of what the probability of that word count occurring given my parameter. So the way you should view this problem is that these authors, so you have two authors, right?
Yeah.
You have two authors, and basically they're not authors at all.
They're machines.
All you do is you hit them on the head and they spit out a number, and that's how long the chapter is. It really is they don't write words, they don't anything. Now, if you wanted to model novels, you could make your generative story better, where you say, I estimate a Poisson, and then based on the Poisson, I get some die, and the die is rolled that many times. Who knows, right? But the point is, here all they are is just number creating machines. I'm sure the Victorians are very happy about this. Okay, so we're just modeling it as this particular case. So given a particular novel by author A, let xi denote the length of chapter I. What is the maximum likelihood value of lambda A? So in this particular case, we want to find the parameter that maxes the likelihood. So our likelihood is, we'll say, star equals our max lambda, and lambda is real valued, right? And it's p of x1, xn, given lambda a, I think I said. So I gave you a bunch of x's. Yeah, okay. So you're given a novel, and I have however many chapters are in the novel, which somewhere I think I say there are n chapters in a given novel. Okay? So that looks like that. And we know that this the form of this. So this equals argmax. So this isn't even anything with EM, like this is just estimation, right? And since we're assuming that the chapters are independent, we can say that this is, actually, let me just write it in convoluted form, equals product of I equals 1 to n x I e to the minus lambda a over x I factorial, right? It's just this. It's just that I'm doing this. Think of it as I'm doing, pick your favorite, likelihood function. I'm just taking a product of these over the I variable.
Where does it say that the chapter lengths are independent?
Sorry?
Where does it say that the chapter
I think
lengths
it's the anthology.
I don't really know. I hope I didn't screw it up. But what do you mean the chapter lengths come in?
are independent? Like you equate
Oh,
the product.
well, I'm just saying that the probability. I mean, I don't model it anywhere, right? So I'm just saying for a given novel, I have a bunch of lengths there.
Next size the chapter.
Yeah. So I'm going by this here.
Okay.
Right? So there's n chapters and n novels.
And X is just the word count.
Just the word count.
The word count for chapter 1 for chapter N.
Yep. So given a particular novel, let xi denote, I hope I said this right, xi denote the length of that chapter. So what's the maximum likelihood of this value? Just based on that individual novel, right? And so we have this. What do we do?
Log likelihood.
Yeah, take the log. So this is my likelihood function, take a log of it, go through, and as always, it ends up being a really simple equation. But
It is lovely.
what?
It was nice.
Yeah, see? It's nice. Okay. All right. Good news, everybody. I really shouldn't make backstories, especially I'm so prone to typos that backstories just add danger. Okay. Okay. So each of these novels are either written by Thackeray or Trollope. Assume that you're not provided by the corpus of M novels. So you don't know which novel comes from each of the authors. Denote the probability of a novel being generated by Thackeray as eta. Provide a generative story for the resulting data collection. As I said, we're ignoring the actual text, so this is clearly a stupid model. But it might work, because maybe their lengths are different.
I think you
I
actually
don't-
said that in the footnote.
I don't know, yeah, right. I don't know if Thackeray and Trollope, I know Trollope's really long, but so is Dickens, probably Thackeray is too. I don't know. Make sure the parameters are required, yeah, so just fully specify the model. So, that was pretty good. Okay. So all I need here is a generative story, okay? So what's my generative story?
You hit
So for every
line.
novel, right? So hey, someone else give it to me and I'll correct it. So how would you describe your generative story?
For every novel, an author spits out a certain length.
Okay, that's part of
Over
it. So that's not the
n
start.
times.
So I didn't. So what's the start of the model? You flip a coin and you get an author, right? So that's my story. Is I flip a coin and get an author, and then once I have an author for a particular novel, I generate n chapters where every chapter length is drawn from the Poisson associated with that author. Is it? So if we want to specify that, what your model would be effectively. So I don't know, did I give notation for Trollope and, yeah, whatever. I mean, really what you have is, so for a given story, right? So I have this vector, right? And so what this effectively is P of, I'm not going to get the notation right, but Trollope. I should have picked Dickens, then I could do D and T, but whatever. P of X given TR plus P of TH, P of X given TH. And then you can carry this through, and these are going to be Poissons, and these are going to be eta, and I don't know which is which now, but did I go right? Eta's. Yeah, well, it's the other way around. But you get the point. And this is my generative story. Effectively, it's two things, right? It's the story itself, how I just described it, for each novel. Pick an author, get their Poisson. For each chapter, draw from the Poisson. Do it over and over, and that's what I'm. This is my joint probability distribution. Obviously, there's more writing than that, but okay. So, if I was to give you the parameters of the defined model, how would you use it to cluster into two groups, specifically into Thackeray and Trollope? Okay. All right, so if we wanted to